Tons of enterprises or small businesses are creating custom chatbot for various different applications. These chatbots are powered by LLMs and are being used by either the employees of companies or by users, by customers, to be able to get to know about the business, to be able to perform their duties in a better way. Now, for motivation's sake, you'll ask, what is an application for such a chatbot? To start, if you are a small business, you can have a chatbot on your website. The customers that come to the website can easily get all their questions answered without going through entire website, without going through all the pages on the website. And these answers would be given by a large language model, which would be able to essentially give them all the information just like a human caller or customer service agent will do. Secondly, for an enterprise company, there is a lot of value in such a chatbot, wherein, as an example, the company can get all their instruction manuals that they use to train the employees, that are instructions on how the employees should perform different tasks. They can use a chatbot with this instruction manuals, with all this information, and all of this together can serve as an instructional guide to the employee. So for example, an employee wants to know how to perform a certain procedure. Instead of scouring through the entire manual, entire wiki pages in the company, they can just ask the chatbot and get precise instruction based on that company's proprietary instruction manual. Welcome back to the channel, guys. My name is Dhruv. I am an engineer at Convolve. At Convolve, we assist small, medium, large enterprises with their custom AI solutions. So if you need assistance, you want to chat with us, here is our contact information. Feel free to contact us and we would be happy to assist you. Now, creating a custom chatbot with a large language model backend for your custom business. This is something we're going to talk about in detail in this video, and I'm going to show you a demo on how you can make such an application. So stay tuned until the end. We have seen enough chatbots on web pages, on websites, which are if-else statement based, where chatbots wherein they are pre-programmed with certain prompts. They look for keywords, and based on those keywords, they would give you answers, or they would give you the links which you can follow. With LLMs, that has changed. The conversation between the user and the bot has become way more human-like. As long as the chatbot knows or has the context of what you're trying to ask, it is very well able to give all the information. So using this technology, a lot of companies want to have their custom chatbots where they can query those chatbots with very specific questions which may not be public knowledge, to be able to give a good experience to their employees, or also to be able to serve their customers in a much better way. So how can you fine tune an LLM, or how can you make a custom LLM based chatbot? Number one option is you take the LLM which has been trained on billions of tokens throughout the web, and you try to use it. If you try to use it, it's not going to work because your specific use case is very tiny and that LLM is very generic. So the first thing that comes to mind is fine tune that large language model with your specific data and use that fine tuned model for your particular use case. Now this approach is a good approach. It may work, and it is resource intensive, though. You need engineering, you need time, and you need resources to be able to get a fine-tuned model. Any changes that happen on your website, any other further things that change, you will have to fine-tune the model again, get a new version of the model and deploy that model. Another method, and this is a very common method these days, is Retrieval-Augmented Generation. This is also known as RAG. That's the acronym for Retrieval-Augmented Generation, and it is very popular in NLP these days to be able to use LLMs with very specific data sets and create custom chatbots. Now, RAG, or Retrieval-Augmented Generation, this is a paper that came out in around 2020. This paper talks about how you can take large language models and you can use your custom data set, feed it to a large language model, and get the language model to provide you information from the database that you feed it. Here on the screen, you can see the paper for Retrieval-Augmented Generation. The link is also in the description of the video. Go ahead and read if you like. For this video, we won't go into the details of the paper, but we would jump into a demo to show you how you can use these technique, the Retrieval-Augmented Generation technique, for a particular problem. Just before we go into the demo, I would like to summarize what each component in RAG is. So the retriever is essentially the system where you are retrieving information from your particular input database. So as an example, say that you have a user manual or you have a website on which you want to essentially you want to use the information from that website for your LLM to be able to answer questions. The retriever is going to retrieve the information, the specific information from the source, which is a database or which is your website. And then the augmenter, that is the step where that particular information is used to augment the large language model. And finally, the generation, that step is the part where the retrieved information from your database, the augmented information, everything is combined, and the generator is going to generate the outputs for your particular input query, taking into account what your query was and all the information that you fed it via the retriever, and hence you will get your final output. Now guys, for the demo in this video, we are going to use this website, Pluto Daycare. This is a daycare in Kitchener, Ontario, Canada. This is very close to our office, so we thought we would use one of this as an example for small businesses, for example, that can leverage the power of these chatbots. So this daycare essentially has some web pages. So there's home, which has the information about the daycare, about their programs, about their unique proposition. Then in the about us, they talk about again talk about their daycare in detail, and then they have a page where they talk about their locations. So this talks about all the different locations that we have. So let's use these pages and see if we can build a chatbot around this. So guys, for this, we are going to use LangChain. So LangChain, for those of you who are not familiar, it is a framework to be able to build LLM based chatbots, and it comes with the functionality to implement RAG, which we are going to use for this particular demonstration. So guys, the first thing we do is from the document loader. So LangChain community is the library, and in there we have the document loader class. We load the unstructured URL loader. So this particular class, this particular function will take in the URLs that you want to load, and it will load that information. So these are all the URLs that we want. So plutodaycare.com, plutodaycare.com, about us, and the locations page. So 3 pages we've looked at. We will essentially load those URLs. So let's go ahead and run this. So once this is executed, this is going to fetch all the data from this website, and it's going to use that fetched data to fill this data variable. So if we look at this data variable, we can see the metadata of this particular variable. It has the source and it has the content. So from the plutodaycare.com, the index page, the main page of the website, it gets all this information about the daycare. Then we have the about us page. It has all this information, and lastly the location. So guys, this is a very small website. Just for the demo purposes, I use this website, but you could have a large website with large information, a lot of text, and it would still be able to do a decent job. In one of the subsequent videos, we will talk about using user manuals, PDF documents from different companies, for example, to be able to retrieve information. So stay tuned for that video. All right, so after we are done with getting the data, now the next thing is text splitter. So guys, this data is large. And what we need is we want to be able to split it into chunks of thousands. So this data that we have is actually not a lot, but sometimes if there's like you have web pages with tens of thousands of words, then over here this text splitter is going to divide all of that text into chunks of 1,000. So we go ahead and run this. So number of documents is still 3 because all of these little 3 documents that we had were already not very long. So they were of the size of they were less than the size of the chunk that is of 1,000. But again, if say that you had a very long text, then the number of documents would grow as compared to what you had in the original dataset. So if we try printing out doc0, it's again the same as this one, which is the from the index page of the website. Now guys, once we are done with this, the second part is to set up the embedding. So now LangChain has different libraries. All of this text needs to be converted to some numbers that a model can understand, right? So your machine learning model does not understand text. It's only going to understand mathematics. So everything that is in text needs to be converted into numerical embeddings. So that's what we're doing here. So this library Chroma is going to take the document, which is your docs, and it's going to essentially say that this is the embeddings we're going to use. We're going to use the OpenAI embedding. So because we are going to use OpenAI's GPT model, so we're going to use OpenAI embeddings, and we're going to convert all this text into OpenAI embeddings. This call here is important, guys. What it's doing is from the .n file is importing the OpenAI key. So if you look, what you need essentially is in your particular folder, you need an environment variable. So here, let me show you. If we do the ls, you'll see that there is a .n variable. This .n variable contains the OpenAI API key. So if you are to access the OpenAI API, you need to have an OpenAI API key. If you don't have an OpenAI API key, you can sign up for an account on OpenAI and create an API key. And then all you need to do is you need to put your the OpenAI API key in the file over here. OpenAI API key, and you just put the API key over here. All right, so when we run this particular document, this particular command, we are going to get the document in a vector store object. So if we just look at what this vector store looks like, is just a LangChain object with all that information stored in it. Okay. Now the next thing is we're going to set up the retriever. Now this retriever is going to take in the text, take in all the information, and it's going to we're going to create the retriever that is able to retrieve information from this database, right? So vector store dot as a retriever is the function call, and we need to set up the search type here. So for this particular application, we are saying that go with the cosine similarity and search for 3 closest documents, or 3 closest essentially pages, in this case documents that are closest to the query that we are passing in. So as an example, here the query is what kind of services they provide. Search is similarity, so our retriever is going to search 3 closest documents from the database that we have, and give us the results. So once we run this, we have 3 docs, and we can look at the retrieve docs. So the first is about Pluto daycare, and this is very much related to the question that we're asking. So this is, again, there is no specific model that is being run here. It's just similarity. So it's basic mathematics that's being applied right now. This is where now we're going to use AI. So we are going to set up the OpenAI's LLM. So this function over here, OpenAI, temperature equals 0.4, max token equals to 500. So the temperature is so here we are basically setting up the GPT model. What we are saying is the temperature is the measure of randomness. This variable can be from 0 to 1, 0 being totally non-random outputs and 1 being completely random outputs or high level of randomness. So 0.4 is kind of a middle ground, and it's able to give us good results. Max tokens is the maximum number of tokens that will be output by the particular model. So after you run the model, the response will be in the length of 500 words, not more than that. So here we basically run that. We have initialized our LLM object. Now from langchain dot chains import create retrieval chain. So these are some of the imports for some of the function calls that we need. Combine documents, create stuff document chain, and the third one is chat prompt template. So firstly guys, this is a system prompt. So whenever we are invoking or we are using the OpenAI API, we need to give it a system prompt. This system prompt essentially says gives the instructions to the LLM. For example, in this case, it says you are an assistant for question answering tasks. Use the following pieces of retrieved context to answer the questions. If you don't know the answer, say that you don't know. Use 3 sentences maximum and keep the answer concise. So this is a sample of prompt that we give it. So this is essentially giving the LLM the instruction on what to do, and then we pass in the context. Now this context is a variable, and it gets filled up by the specific retriever documents that have been retrieved by the retriever. So what happens is you feed in the query. That query is fed into the retriever. So whatever the query goes into the chatbot, that goes into the retriever, and the retriever will retrieve the documents. These documents will go into the context of the system prompt, and together with the input query and the context, the LLM will then give you the answer. So now that we have set this up, the next is question answer chain. So we are essentially creating a document chain with the LLM and the prompt. And then we are creating a RAG chain with the retriever and the question answer chain. So this is essentially saying that we have created a chain with the retriever object that we have created, and then this question answer object contains the prompt and the LLM that we're going to use. Again guys, in this video we are using the GPT OpenAI, but you could use any other LLM as well. This framework supports that. So now that we have set all this up, RAG chain is the final chatbot that has been generated for us. This object is where you feed in your chatbot query and you will get the answer. So let's say the query is provide the address for all the locations. So now we have Pluto daycare and we want to know the address for all their locations. So if I run this particular query, the answer is Pluto Daycare has 3 locations: 192 Activa Avenue in Kitchener, 1418 Weber Street East in Kitchener, and 435 King Street North in Waterloo. Each location has a unique phone number and email address for contact. So let's go and check. If you look at the locations, you'll see 192 Activa Avenue, 1418 Weber Street East, and 435 King Street North. So guys, is able to essentially pull that information directly from the website and give you accurate answers. Now that we have this demo, we have gone through this IPython notebook. How can we create the chatbot? How can Pluto Daycare use all of this code, all of this information, and have a bot that can be placed on their website, or have a bot that users can directly use? So let's show you a sample for that. For that guys, we have this code here. It's very similar. The only new thing is Streamlit. So we are using the Streamlit library, which is going to act as an interface. So it's a UI interface between the backend, which is this model, and the user who is inputting the query. Over here, all of this is similar. So we load the environment, and then Streamlit title is set. So for the chatbot, we set a title. We give it the URLs that we want. Then all of this code we have already seen. We load the data, we split the data, um, we set up the retriever, and then we set up the LLM model. At the same time, now here this chat query. So this essentially for the chat input box. We will this is what will be displayed. So we'll see this when I go to the chatbot to show you. Again, the system prompt is the same here as we've seen. The context is filled in by the retriever. Then comes the prompt, which is again the prompt to your LLM, which includes the system prompt and the input from the user. And based on what the query is, if a query has been provided, then the question answer chain and RAG chain is initialized and the response is written on the screen. So this function here is going to write the response on the screen. Now let's see a demo of this particular app. So guys, here is this app already running. Just to show you how to run this app, all you need to do is, let me close this. So once this is closed, this is the command streamlit run app.py. When you run this command, this application will be initialized, and here you can see this application that has been initialized. It'll take some time to load. Once it has loaded, you can see the thing over here essentially shows that it's loading, and once it has loaded, then we can ask it questions. Now here you see Pluto Daycare chatbot. This is the title we had set, and then here you can see, hi, I am a Pluto assistant, how can I help you? This was what we set for the chatbot message. So let's say we say tell me about Pluto Daycare, and let's see what it comes up with. This is the first time I'm feeding this question to it. Pluto Daycare is a progressive early childhood education center that focuses on meeting unique needs. They provide nurturing. So let's now, this is a very generic answer. I mean, the question was pretty generic. Let's ask it a specific question. And say the user again comes here. Could you provide me the locations in Kitchener, Ontario? And let's see what it says. So guys, here you see it's able to give the locations: 192 Activa Avenue, 1418 Weber Street East, and then it basically gives you all the three locations. Although two of them are in Waterloo, but they're close enough, so it's able to give you that. So this is an example how you can set up a chatbot for your particular business. Now guys, that was the demo on creating a custom chatbot using your dataset for your particular business need. For this demo, I would like to give a huge shout out to Aarohi Singhla and her YouTube channel. The video on RAG and LangChains was a huge motivator for this demo and for this video. So thank you, Aarohi. So guys, as I've mentioned before, in this video, I specifically talk about a small business making a chatbot for with the information on their website. But if you are a large enterprise, another big use case is using your operation manuals and creating a custom chatbot for your employees that can be used by them for generating instructions, for getting SOPs, for finding out specific instructions on how to do different tasks. This can save your employees and your company a lot of time and money. That's it for this video, guys. If you like this video, please hit the like button, subscribe to the channel, and hit the bell icon so you are notified about any new video that we upload. Thanks a lot for watching, and I'll see you in the next video.